Okay, so we've seen what it's like on a function check plate. Let's see what it's like on a real weld.
Okay.
So we've got a carbon steel plate, and on this plate there is a weld running down the centre line. We've actually got a couple of flaws in here which should show us what a defect signal is going to really look like. So this is our pencil probe. Inside the probe there's a field inducer, and what that does is it creates a very small current to flow in the surface of the metal. Now when that current is disturbed by the presence of a crack, the current flows around and underneath the crack, and those disturbances are also shown in the magnetic field just above the surface of the plate. Now in the nose of the probe there are two very small sensors which sense changes in that magnetic field. One of the sensors is called a BX sensor, and what that does is it records changes which are related to the depth of the defect. The other sensor is called a BZ sensor, and that indicates where the ends of the crack are located. So as we place the probe onto the surface of the plate, those currents are going to flow across the weld line. We now move the probe along the toe of the weld, and we're going to cross our first defect, which can be seen in the software.
And Mike, just give me some more details of what we're looking at on the screen here.
Okay, so what we're seeing is the BX sensor dips down as we pass over the defect, and this dip is related to how deep the defect is. But at the same time, if you look down at the BZ sensor, we see that we have a peak at the beginning of the defect and a trough at the other end of the defect. So this is giving us our physical length on the surface. And as we'd expect, the peak and trough lie either side of the dip in the BX. So we have a start of a defect, the middle of a defect, and the end of a defect. So this is a really good and clear defect call. What we see over on the right-hand side is you'll notice another display. We call this the butterfly display. It's not actually a third sensor. What it is, it's the combination of the BX and the BZ signals plotted out onto a graph. So we plot the BX signal vertically, we plot the BZ signal horizontally. And what happens is that this particular plot really helps to decouple the speed of movement of the probe, because when the probe is moving along and the signals are fairly quiescent, we notice just a small spot in the middle of the screen. When we actually go over a defect, it produces this loop effect. And the loop travels in a direction which is associated with the direction of movement of the probe. Now, I deployed the probe in an A direction, i.e. the label letter A on the probe was actually pointing in the direction of travel. And that will form an anti-clockwise loop in the butterfly. If I actually moved that probe in the C direction, what I would have found is that loop instead moves in the clockwise direction. So this is a real additional piece of information to help an operator interpret cracks and flaws from any other type of noise signal or influence from the weld that he might be seeing.